Okay, good morning, everyone. Okay, let's uh, other join. Okay, we have a few in number. We'll start in a few minutes. So this would be your most probably last class of your network theorem, and that we will discuss on the things what we have seen, or I would say I have provided you to solve at your home. Okay, so anybody who have solved may please show up. I would be if you have done, please tell me so that I could ask you to share the screen. Okay, and we could discuss that. Else I will drop. So first of all, we'll see what questions that we have given you. Okay, this was the very first question from last 3 days. I am giving you. I need perfect answer for this. Okay, this will provide you. Uh, this question was very good. Okay, if anyone has solved, it would be your very nice thing. Just hold a minute, yeah. Okay, let's start. Okay, the mic was off and I was telling something. Okay, so plus minus. Okay, so this was the question what been provided you way early. So yet I haven't given got any questions or any response from your end. So I thought that I would be explaining. So, but my suggestion would be there and request as well. You could account in any of the factor that you need to solve this. Okay, it's not my part. Okay, I have already been known how to solve, and I'm uh, doing more and more thing, and I'm also learning from you all as well. So if you solve your part very nicely, okay, this will help. Okay, this will be, I know everybody knows these kind. Okay, you are studying from last complete year, you have studied again as a revision part. So I came that if instead of going lot of thing, we would practice more and more things. Okay, so what was the question? This was a question to find, okay, that is your Thevenin model, and ISCN, that would be your Norton's model. Okay, this was the question. Okay, first of all, we'll go with the, okay, now for finding this Thevenin model, we'll seek about something. We'll change color and we'll do. Okay, we have to bring out the equations out. Okay, from which we could find easily. Okay, so from this we could see this segment over here. There would be no loop part, and there would be a this segment. Okay, from using these two only we could easily get it. Okay, what we have to find? VOC, right? So VOC is this one. Or we could write into this manner: VOT, and this is equals to VOC. Okay, in this form we could see. Okay, so from equation 1 and equation 2, so let's write equation. First one is equation 1. Okay, 2 into 10 to power minus 3 would equals to 2 into 10 to power 3i. Okay, there will be I1 means over here. This is your I1. Okay, this is the direction of I1. Okay, plus VOC by 500. That is your V2. Okay, this is your V2 or VOC, whatever. Right? Let's write VOC only. This is your equation 1. Okay. Now, what will be the equation 2? This part. Okay. it will be a 0 equals to 20 into 10 to power 3 into 50 I1 plus VOC. Okay, I will tell you how. Okay, we are considering this, or we could say we are considering this segment. Okay, we'll tell you. Okay, this is the current flowing over here. Okay, and this segment is the only thing which is flowing. This is the path. Okay, so this is the path. Okay, or we could call this is the path where this would be your I2 equals to 0. Okay, so this is your equation 2, right? We'll write over here. Yes, Asif. Okay. Hmm. That's what I have written, Asif. Thank you for writing in WhatsApp. You could say, okay, I have asked you that you could unmute and you could say, okay, it doesn't matter. Okay, this is your equation 2. Now, what is our task? Our task to find VOC. So from this, we could easily find the VOC part. Right? If we substitute the value of this into that, okay, we could easily get the VOC segment. Okay, so these are there. So if you multiply into 100 in this segment, so it will be your 2 by 10 would equals to multiplied, okay, into 100 means 1 2 is gone, would be VOC by 50 plus VOC. Okay, right? So we could get, okay, it will be 10, wait, if I'm not wrong. Okay, no, I'm wrong over here. I will write. Okay, 2 is there, only this segment is missing, means it will be multiplied by 500. Okay, this would be a minus minus minus. Okay, so 500 means 1 200. Okay, or 10. Okay, this would be deducted. Okay, over here would be your into 500, right? Into 500. So 112 will be there, will be left with by 10. Okay, so it will be 1. So 1 is equal to VOC by 10 minus VOC. So you will get VOC equals to minus 10 by 9 volt. Okay, this is what we are getting as a answer. Okay, for VOC segment. Okay, that is your VOC segment. Now to find R equivalent. Okay, to find R equivalent, as we know, in this particular circuit we have two dependent source. Okay, and this would be eliminated. So what we have to do, we have to add either 1 volt or 1 ampere current. Okay, in that. So we'll see. We'll draw the circuit first. Get. Okay, I'll draw with hand only. My stylus is again, it's not working. Okay, so for this we'll add 1 volt. This is your again 20k. This is your again 50i. This is your V2, right? So V2 is 1, so it will be 1 by 5000. Okay, so this has been done. Okay, so this is your now equation, right? Now you have to solve it. Again, if we go through according what it is been given, okay, so it will be 2 into 10 to the power 3 I1 plus 1 by 5000 equals to 0. Okay, this is your I1. Okay, this would be your so I. So this is your equation 1, and for 1 would equals to your 20 into 10 to the power 3 I minus 50 I1. Okay, I minus 50 I1. The current in this as 50 I1 is flowing in this particular form. In this we are getting 50 I1. Okay, so we'll seek about this segment. That will be your I minus 50 I1. Okay, let me write it nicely. Okay, would equation 2. So on solving this, we could easily find, right? We could easily find what is the value of this resistance. Okay, so as we know, v that v equals to IR. Okay, then so R would be V by I is 1, so R equivalent would be your I by R would be equals to 1 by I. This is what we have to find. We have to find the value of I, and from these two equations, right? So we'll see how we could find. If we go with the previous method that we have gone, okay, according to that, it will be very convenient to solve. Again, what you have to eliminate, this I1. Okay, this is what you have to eliminate. Or you could substitute this I1 value from over here to here. Okay, so it will be coming as your 1 1 by I, that is your R equivalent, would be coming around 20 by 9k. Okay, this would be a segment. So this will be remain constant for your 10 mm and the under segment. Okay, now what is left with your ISC? We'll seek about ISC first. Okay, R equivalence is done. We'll draw the both the models. Okay. Okay, why this has been happened from the original, right? Because over here v2 is equals to 0, so this was your v2 by 5000. Okay, this was the v2 by 5000. When this is 0, so it will be eliminated. So we have also sort. Now over here he needs the current needs the shortest path. So when shortest path is there, so for that segment, this current would not flow from this particular division. It will be flowing from this particular part. So that's why that is also eliminated. Okay. Now, so we left with these two figure. This figure. Okay. We'll see how to get the answer from this. Okay. So if we write equation, it will be 20 into 10 to the power minus 3 would equal to 20 into 10 to the power 3 minus, sorry, into I1, okay, where I1 value would be 10 to the power minus 6, because these come, okay, and it will be, sorry, okay, will be your 20 into 10 to the power minus 3 would equals to 2 into 10 to the power 3, okay, I1, okay. So this 2 gone, right? 10 to power minus 3 by 10 to power minus 3 would be down, that is your I1. So it will be your 10 into 10 to power minus 6 equals to I1, okay. This is what we left with. So it will be 10 into 10 to power, or I1 would equals to 10 to power minus 5, okay. This would be your answer. Now we know that ISC equals to minus 50 I1, so your ISC would be minus 50 into 10 to power minus 3, okay. Or you could write 10 to power ISC would equals to minus 5 UA, okay. It will be 6, so it will be. So this is what we are left with. That is your answer, okay. No. I made a mistake. I made a mistake. Just a minute. Huh? I made a mistake. It will be 2. Okay. 2. 10 to power 3. 10 to power 3. Okay. We'll remove this. So it will be your 10 to power minus 6. Okay. And if that would be 10 to power minus 6. It's 2. Okay. It's 2. It's not 20 or 20. It's 2. Okay. So then I1 would be 10 to power minus 6 only. And we know IC equals to 50 I1, that is your minus 50 into 10 to power minus 6, then equals to minus 1050 into 10 to power minus 6, that equals to minus 50 mu ISC. This is what you can write, okay. This is the segment, one segment you have to know very clearly, okay. Now okay, the other question, what let's solve fastly, okay, what I asked. Okay, this is what current is falling, and what you have to find, you have to find Z in, okay, you have to find this, right? Now, so what is being given over here, okay, what is, first of all, it is I, okay. I is your V1 minus V2 by R, so it is your 5 minus 3 by 1 M, okay. So it will be your 2 ampere. This is the current, right? Now what will be your Z in? Z will be your V2, as the nearest voltage is this, so it will be V2 by I, so it will be your 3 by 2 mu, okay. So it will be 3 by 2 milliohms. So this is the answer. This is what I gave you as a question, okay. Okay, fine. Next question was, Okay, this is a question and you have to find V0. Okay, sorry. Okay, this is a question. You have to find V0. So how you will find the V0 first? Okay, the most important thing would be your how to find the V0. Okay, now if we seek, or if we draw, or if we assume one particular segment, and that is this particular loop, okay, or this particular segment, you could easily find your this now. So voltage drop across this, voltage across this is same. So over here would be your 100 volt. Okay, in this particular point, it will be 100 volt. Okay, now, so what will be your V0? V0 would be your, okay, across this, means across this particular terminal, you have to find voltage. Okay, so what will be, how you found the voltage? It will be using current division rule, that is your 4j by 4 plus 4j plus 3 into 100. This is what we got. Okay, that will equals to 400j by 3 plus 4j. Okay, this is what we got. Okay, now if we want to remove this particular segment, okay, you have to remove this particular segment. What you could do, multiply 3 minus 4j by 3 minus 4j. Okay, so what will be the equation now? Okay, will be your 400j 3 minus 4j by a plus b minus b means a square plus b square, so it will be your 9 plus 16. Okay, so this will be 400j 3 minus 4j by 25. So 25 1 ja 25 4 16 ja. So your V0 would be your 16 3 minus 4j. Okay, 16j minus 3j by, no, this would be the answer. Okay, if we multiply 16 3s are right, 48j plus 54. So we could write 54 plus 48j. That would be your V0, what we have to find. Okay, okay, this was the, is it okay? We have done with 3 questions. Let's see if any question was left. Else we will end this. Yeah, one question over there. We'll solve that and we'll end up. Okay, this was the question. Okay, this is the question, that is your A and B, and you have to find Z equivalent. Okay, now this figure, if we solve very frequently, okay, we could precisely could solve, it could be converted into this form. Just a moment. Okay, current P, your IB. IB, yes, IB is following following that direction. This is this your 99 IB. Okay, this is your A and B part. Okay, now what was the R concern? R concern was for Z equivalent. So you know, whenever you have to find Z equivalent, what you have to do, you have to add a 1 volt this. Okay, now we also know what I equals to 1 by I, right? And this part will be your I, that is your current flowing into this direction. So if we follow this particular direction, and this direction I will change, okay, this direction I will change, I will mark it from black, okay. See, if current is coming from this particular direction, okay, so this is your 1 volt, so at this particular point as well, it will be 1 volt, okay, so 1 volt will be common for all, right? So if we say that current is coming from this particular direction, so it may be this, this, right? So instead of that, we'll use nodal and we could solve, right? So 1 minus 0 by 100k, okay, plus 1 minus 0 by 10k. In this, it is your already minus 99 IB, okay, minus I equals to 0. Now we got the I value. Okay, this is your equation 1. Okay, that is your equation 1. Okay, now, so from this, after calculating, you could find your minus IB equals to 1 minus 0 by 10k. Okay, if we select this particular segment only, okay, any of the segment, okay, let's consider this particular segment only. This is your IB, this is your IB, okay, this entire segment is your IB. So from this you could find minus IB equals to 1 minus 10k. If we substitute that value, so your 1 by R, that is your R equivalent, would equals to 0.1k, that is your 100 ohms. This is the answer. Okay, so we are done with this. So thank you for coming, and thank you for being patiently waiting for us.